guys came back. It's really sweet. Let's do this. I'm not going to give you guys a number on this. Check the title for this if you're in my class. I figured that'd be easier in case semesters change around and things like that. So we're going to be talking about solving systems by graphing. And we've got two equations here. I got to make sure this is timed out. I did a whole entire one of these and it didn't hit record. Dumb, Mr. Hayes. Anyway, so first things first. This step, if you're doing this from outside my class, you may want to skip it. Basically, you're going to graph the lines, but I usually suggest solve for y. Some of you guys may be looking at that first equation and saying, oh, wait, I can just solve that by intercepts. That's fine. If your teacher taught you that, no problem. But we're going to play it safe. We're going to go through y equals mx plus b form, so everything's kind of consistent and the same. So I'm going to take this equation here, 2x plus 3y is equal to 6, and you're going to go through and solve for y. The bells here are going to ring here in a second. So when you go through and do this, you're going to go through and we're going to move the 2x. I'm going to do both of these questions in two different colors so we can see where the lines go a little bit easier. So you get 3y is equal to negative 2x plus 6. Divide each part through by 3. So y is going to equal negative 2/3 x plus 2. And that's this equation right here. Step 2 is we're going to graph these beautiful lines. So graph lines on same axis. So you graph them on separate axes, that's no good. Remember, you can always pause, rewind, etc. Now, when you graph these, the one thing I would like to point out is that you could, if you wanted to, take a look at your intercepts. I've got a 2 and I've got a 5. And so that tells you most things are going to happen above the x-axis here. And so when you graph out that x-axis, when you set up the x-axis, you could potentially put one a little bit lower if you wanted to, so you've got more room to mess around with things on top. Just a thought. You don't have to. If you end up moving it right here, that's fine too. Either works. I have x and y. And then I've got my slope of negative 2/3. Remember, of course, that is y over x. Let's say change in y over change of x. And my y-intercept is going to be at 0, 2. So when I graph this, I'm going to start here at 0, 2. And go down 2 to the right 3. Down 2 to the right 3. And I'm going to draw my line. When you draw your line, remember to extend it all the way through the points, out the edge of the graph. Especially when you're trying to solve by systems, you don't know where the intersection is going to happen, so that's important. And because we're not barbarians, we're going to make sure there's arrows on both ends. And I'm going to do the same thing with the red one. So I'm going to do this one here in red. My slope equals 1/3. My y-intercept is going to be at 0, 5. So in this case here, I'm going to start this up here at 0, 5. That's 2, 4, 5. If you're wondering why I didn't label my axes in terms of numbers, I have an unwritten rule. You assume everything's by 1 unless you say otherwise. Slope's 1/3, up 1 to the right 3, up 1 to the right 3. So I've got that. I'm going to draw our lines in here. Wrong menu, sorry. And then again, remember, you're going to extend through the edge of the graph. And I'll clean that up here in a second. Always draw with a straight edge, especially when you're doing this, because otherwise it's just, you're going to end up getting messy stuff. And so here, even as awesome as I am, you get to see where the intersection is. It's still a little bit off. So 3, your solution is at the intersection. So in this case here, your intersection is right there. And the two places where people make mistakes on this because they kind of let their brains go on vacation is that they goof the slope up, or they also reverse the two coordinates of the point of intersection. So be careful of that. So x comes first, negative 3, 4. And remember, that is saying that negative 3, 4, if I were to plug in, so if I were to take this x of negative 3, oops, and plug that in to here and to here, I would get a y value of 4 out. It's the only place that works for both lines. That'll get the same answer either place. And we'll talk more about that when we start getting into real-life adventure problems in about a week or so. All right, last part. Two special cases. And for these, I'm not going to go through and actually work problems. We're just going to say, because I'm assuming that you guys know how to graph lines, we're just going to say what happens if you see lines like this. Okay, so I'm going to draw some axes on both of these graphs here. And the first special case happens when we get parallel lines. So draw the parallel lines however you want. They can both be horizontal, they can both be vertical, they can be negative slopes, positive slopes, just as long as they're not intersecting and they're the same distance apart. So if I get parallel lines, okay, means that, so if I have no intersection, that means I have no solution. I should probably even write the word means down here. So no intersection means no solution. They don't intersect. So there's no points they share in common, and that's basically what we're looking for. On the other side, you can come up with the same line. So I'm going to draw this a little differently. I've got the one line here, and when you go to graph it, you actually get the same line just on top of it. And so that means you end up having an entirely, I mean, the whole line intersects, whole line. So that means that it's infinitely many solutions. Some of you guys write that as IMS. But those are the two cases. And the big tip-off that you have a special case like this, remember, is that you end up with the lines have the same slope. And that's the other, that's an ugly M. That's the other reason why, if you write them in y in slope-intercept form, y equals mx plus b, you can sometimes see this faster. So if you ever see lines with the same slope, you're like, ooh, special case. And you can just tip that off. So anyway, that should get you through. I have some good examples to refer back to for solving by graphing. We got some steps out there. We did them in different colors, so it's easier to see. As always, comment below, make suggestions. I'll see you in class. Like, comment, subscribe, share, come up with a favorite recipe, whatever. So, talk to you later.